Okay, so this morning, as I said, we're going to look at angle, side, angle, and angle, angle, side. So this will give us two more ways that we can prove our triangles congruent. And this is lesson 4.5. Let's start with angle, side, angle. So here's what it says. It says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Again, for angle, side, angle, it's all about the placement of where the side is. So remember we talked about an included angle when we did side, angle, side. With angle, side, angle, we're talking about an included side. So the side is in between the two angles. So you'll notice here AB is in between angle A and B. ED is between angles E and D. So this would be an example of angle, side, angle. Okay, let's take a look at an example. So here in this picture we have parallelogram RPQS. This is a Q. And we've got some angles marked. So we have this corner angle marked as being congruent to this angle. This corner angle congruent to this one. And then the side that lies between the angles is also the same in both triangles. So in this picture, I could assume that the two triangles are congruent by angle, side, angle. Now, if I'm going to write the congruency statement, again, it's just like with the other ones, important that I match up the corresponding parts. So if I start with PRQ for the first triangle, I know that angle S corresponds to P, so I'm going to write S first. The R corresponds to Q, so it's SQR. So again, important to match up the corresponding parts there when we're naming the angles. Okay, our other way that we're going to look at today is called angle, angle, side. And here's what it says. It says if we have two angles and a non-included side of one triangle that are congruent to the corresponding two angles inside of a second, then we can say the triangles are congruent. So notice, with angle, angle, side, the side does not have to be included. So in this picture, they've marked BC and FE. So notice if I go around the triangle, angle, angle, side. Notice the difference between angle, side, angle and angle, angle, side. Okay, so here's what I want you to do. We're going to go to this slide here that has 4 pairs of triangles. What I would like for you to do is I would like for you to look at each pair and determine whether or not it is angle, angle, side or angle, side, angle. So look at pair 1 and make that determination, then look at pair 2 and make that determination. And what I want you to do is type in your answers into chat one at a time, and then I will let you know if you're correct or not as you move through those. For pair number 1, you should notice that around the triangle, it's angle, angle, side. So number 1 would be AAS. Number 2, hopefully again you notice as I go around the triangle, angle, angle, side, angle, angle, side. So it's also AAS. Number 3, also angle, angle, side. The last one, you should notice that the side is included, so this is the only one that is angle, side, angle. So hopefully going through that process helps you to see the difference between those two ways to prove the triangle's congruent. All right, we're going to go ahead and move on to our proofs now. So if you want to go ahead and click to proof number 1. Again, I'm going to go through these first 2 together and then give you a chance to do one on your own this morning. So proof number 1, here's what we've got. They're telling us that AB is parallel to ED. And they're telling us that AC is congruent to EC. And that's our given. So pretty similar to what we've been doing all week in terms of our proofs. We're still trying to prove triangles congruent. So you're still going to be using some similar steps. Something that I think is always maybe a good idea to do when you're looking at your pictures is when you notice you've got some vertical angles, put some numbers in there. So I'm going to put a 1 and a 2 on my picture. Because they're telling us AC and EC are congruent, I'm going to put a little S next to that so I know I've got one pair of sides. Now I'm going to utilize my given. AB is parallel to ED. Well, if AB is parallel to ED, that tells me I'm going to look at my angle pairs. So I can either look at these 2 angles, which those are the 2 I'm going to pick. Hopefully you recognize that those are alternate interior angles. And when the lines are parallel, those are congruent. So I'm going to say angle A is congruent to angle E. And that would be if lines are parallel, alternate interior angles are congruent. So that gives me a pair of angles. So I have an S and I have an A. So I either need another pair of sides or I need another pair of angles. Hopefully you recognize here that 1 and 2 would be congruent because they are vertical. So I could say angle 1 is congruent to angle 2. That would be vertical angles congruent. Now I have another angle. Now if we go back to our picture, I go around the triangle. This is angle, side, angle. Angle, side, angle. So I can now, in my 4th step, say that triangle ABC is congruent to triangle EDC by angle, side, angle. Okay, let's look at proof number 2. Here's what proof number 2 says. It says LM is congruent to NO and M is congruent to O. So if we fill in our given, for this one, LM congruent to NO, angle M congruent to angle O. So we've already got marked those 2 things. So we've got a pair of sides and we've got a pair of angles. I'm again going to put some numbers in here, 1 and 2. Hopefully you recognize those are vertical angles again. So I'm going to say angle 1 is congruent to angle 2. That's all vertical angles congruent. So we're going to say triangle MPL congruent to triangle NPO, angle, angle, side. Now on proof number 3, here's what I want you to do. I want you to go ahead and try this one right now on your own. Okay, and I'm going to go ahead and put in a couple angles, 1 and 2 there in the middle to help you. But what I want you to do is I want you to go through and see if you can go through the proof. We'll start, obviously, we'll write down the given together. AE bisects BD, and A is congruent to E. So what I want you to do, and I'll just tell you on this one, there are 4 steps. So see if you can fill in the 4 steps. I'm going to give you a little bit of time to do that, and then we're going to do just a self-check to see how well you did. So you do a quick check here as we go through it, see how many out of the 4 steps you get right. So my second step that I would have made, I would have said angle 1 is congruent to angle 2. That's all vertical angles congruent. Now, if this was your third step, that would be okay. You could flip-flop steps 2 and 3. So all vertical angles congruent. You'd also want to have in your in your steps, since AE bisects BD, I can say that DC is congruent to CB. That's going to be definition of a segment bisector. So now I have a pair of angles. Two pairs of angles. So angle here, pair of angles here, and a pair of sides. So now I can say that the 2 triangles, ABC and triangle EDC, that those are congruent by angle, side.